Good evening. So now we are going to discuss about response simulation. And I have an example. This is a component which is having some concentrated mass on the middle. So I'm taking this model for this response simulations analysis. This is the model. So I'm going to advanced simulation and I'm defining FEM, and this is very important thing here. When you entering into FEM part, you should choose geometry option, and in that you should select line. If you didn't select line, you can't able to select this line while giving the loading condition, because we are going to use this line for our loading condition. So we need to select that line. So until otherwise, if you didn't choose this one, if you're not select the point or there in the line. So you should choose the line option, otherwise you cannot do it. So I did, and I'm continuing with the problem. So I'm creating a mesh collector. Mesh collector, since it is the model, we're creating a 2D tangential mesh. So I'm taking into it material I'm assigning, and the thickness I'm giving 1.5. Okay. So now the mesh collector for 2D mesh I created. Now I'm going to create a 0D mesh. 0D mesh in the sense I have to create a point and I have to mesh the point. How can I do it? So it's very simple option. You have to expand the mesh option. So there you will find mesh point. Otherwise you will find it in the toolbox in the previous versions. There is a mesh point constructor. So this construct a mesh point. It's a point or any, so I say projected point on the surface and exactly on this midpoint of the line. So now I can able to select the line since I selected the line option in the options. Now my mesh point has been created. Now you can see there is a triangle symbol which showing there is a mesh point. So before entering into the 2D mesh, I'm doing the 0D mesh. The same in the mesh option is 0D mesh option. So there I can enter into the 0D mesh, and this is the property of the 0D mesh. So I'm CMM2, that is means concentrated mass 2. I'm editing the parameter. I'm giving some off kg because that is going to be bear some off kg of weight. So I defined it, and I'm selecting the point. Now I did. Now you can see CM. CM in the sense it's a concentrated mass. Now I can go with the 2D mapped mesh because this material I need a accurate mesh. So I go with the 2D mapped mesh. I'm selecting surface, this surface. I'm giving a mesh size. So make sure your mesh collector is exactly as you defined. So then say okay. Now we can see the created my model. This is my full model for my simulation. I have been created. So now I'm continuing with my simulation model. Right click and I'm going with the simulation. I told you this is the solution for response simulation. So I'm taking this response simulation solution and I'm continuing. So this is here you will find three subcases: static, three subcases: static offset, static stuff, static dynamic. So my subcase static dynamic is active right now. So I want to edit some values in that. So that I right click that subcase dynamics. I say edit values. So in that output I need acceleration output. So I'm just enabling my acceleration output. Any other outputs you should do enable. Otherwise that outputs will not be available for your result. So another thing I'm going to edit here. I'm going to edit my frequency. In the sense 0 is my lower frequency, limit, and upper is my upper limit. So a defined frequency level which can be so I select. Now put some boundary condition for my component. So the boundary conditions are, one is user defined condition, that is for this phase, and here the duo of 3 I'm giving as fixed. Sorry, I'm giving all, and the duo of 3 I'm making free. That means degree of freedom 3. So degree of freedom in the 3 is x-axis, which is going to be free. Okay. So sorry, z-axis, which is going to be free. So I made. Now you can see this is a constraint, and one more constraint I'm going to give on exactly top of this nodes. So that constraint is enforced motion location. So there is a enforced motion is coming, so that I'm defining that particular nodes to be enforced motion exactly on degree of freedom 3 is to be enforced, and define the both. Now this is my boundary condition and this is my component. Okay, so now I can go with solution. So I can solve this problem. Sorry, actually I have a lot of problem in my software, so I'm unable to show the result of the problem. So if you go with the book, you will find a lot of solution types. There you can have some graph generation, big steps are there. So from that you can see the graphs, you can see the results, and you can get the some the ratio between displacement and acceleration and transmissibility, and the graphs for acceleration, graphs for stress, and all those things you can get a graphs. So that is main advantage in this. So you can get, just go through the book, you will find those things. Thank you.